Thank you all for joining this session. My name is Klara Santer, and I will talk about human-computer interaction for building documentation, research that I carried out at the Georg Nemetschek Institute. So one of the key tasks of European building professionals is to manage the existing buildings and the interventions on existing buildings. And for this purpose, first of all, the current state of the buildings needs to be documented. A lot of workflow automation for scan-to-BIM workflows has been proposed, and it is an active research field. However, personal responsibilities of building professionals require on-site visits of them. And therefore, as the current practice of scan-to-building information modeling is to capture point clouds on-site and post-process them off-site, I propose a more interactive and human-centered approach with interactive point cloud capturing and real-time documentation. And this can enhance the use of three-dimensional building models, for example, for building information models, digital twins, or even digital building logbooks. However, the challenge is to make this approach human-centered, as I said, and therefore I followed the instruction of the international standards on human-centered approaches for the development of interactive systems. So first of all, in this human-centered approach, we need to understand what is the context of use of a certain systems, and for this purpose, I carried out an exploratory study in order to get findings in regards of that. And for my end goal of developing a human-centered interface for interactive building documentation for different stakeholders that in the future will be personalized to the different stakeholder needs. The difficulty is that there is no digital system approach yet adapted by the different professionals. So this means that we have to start with the current state of how professionals document buildings. For example, this is also done in many other cases. We can look back when the PC desktop systems were developed. At this stage, we had to first ask people how they organize actually their physical desks in order to be able to propose a good desktop system. So in comparison to the presentation that we had before, I start with no building information model at hand of a building, and I try to engage people with an interactive approach of creating it. Therefore, I interviewed 4 different groups of building professionals with an approach of semi-structured interviews. That is a very common approach in research, human-computer interaction research. And the questions are predefined, but in the semi-structured interviews, they can be slightly adjusted by the interviewer, and they are followed by prompts and probes in order to encourage the professionals to share as much information as possible. I try to first get an overview from them of the whole process of an intervention, so a retrofit or a renovation for a certain building. Then I try to find out how they prepare for their on-site task of building documentation. I wanted them to walk me through exactly their usual documentation visit. And then I also asked them what are their post-processing practices, so what they do with the information they collected after these visits. I will limit myself to some findings in the presentation for the limited time, but you can find more in the paper. So specifically, I will go into the different tools that people use during their documentation tasks. So still, people mainly rely on paper-based methods alongside with mobile devices for image data collection. But they also use specialized equipment for each specialized professional task. Many of them study the existing documentation before the first site visit, but oftentimes such documentation is not available or incomplete. And they agreed that if it is available, it is mostly two-dimensional data that is at hand. Next to that, so next to viewing the existing drawings, they also refer to other sources such as satellite images or previous interventions or the knowledge of different stakeholders that were involved. And one of the interviewees uses actually mobile LiDAR technology for capturing a point cloud of the existing buildings. However, at the same time is using a paper-based approach for noding other information that is not captured in the point cloud. They also use different tools such as laser devices for including check measurements in their documentation. And they also mentioned the risk of not being able to recall the in situ conditions. So they try to take as many pictures as possible in order to remember the on-site conditions or possibly take 360-degree pictures. In terms of the information that is collected, the interviews indicate that it varies according to their specific tasks for the given intervention. And identified user requirements I discussed in the paper. Although there are numerous project scenarios that were identified, the information collected is similar within the group of interviewees. Of course, these people as professionals refer to different information, such as the architect is mostly interested in the spaces in the building, the energy professional is mostly interested in the building envelope and the geometries in regard of that, and the structural engineer is mostly interested in the load-bearing building parts as well as the damages and the materials. These visits are followed by multiple intervention proposals and discussions, and this is an iterative process. And in this process, professionals collect performance data such as energy consumption that they then use to try and calibrate the models. These professionals mentioned that they want to start this iterative process as early in the process as possible in order to engage better with the clients. So with this in mind, I started working on a use case after submitting the paper at this conference. And at first, I considered the case of the energy planners. However, during the initial testing, where I carried out several think aloud studies with my interface that I developed, it became clear that I have to consider different expertise levels. So I included owners and building inhabitants that have no domain knowledge in order to be able to create a bottom-up approach for the data collection task for everyone involved. So the interface developed is shown in a quick video here. There are some instructions. I can once again confirm that users don't read instructions. However, they figure out their way to use an application anyway. Oh. So the detected elements, the interface can show the detected elements. And once this is done, they can be interacted with. So they are detected as wall or windows, or whatever building part is found. And then we can tap this building part and insert specific information in regard of that. So if a wall is detected and we tap it, we will find the interface for inserting specific information regarding this wall. And if it's a window, then we can find a different input view. And then, as I said, we have different levels of expertise, and therefore I gave the option to have an advanced input view for different building parts in order to also give options to more experienced planners or professionals to provide them with the right input possibilities. Once this information collection task is completed, in the future we plan to make visualization and energy analysis available on a web server directly after the information was collected. That is shown here. For the development, different Apple iOS frameworks were used, such as the RoomPlan API for measuring and detecting the elements, RealityKit for the visualization of such, and SwiftUI for enabling the interaction with the building elements shown in the augmented reality view. The export is then done as a JSON file, and we exported this information to our web server. And in the future, we are planning to provide estimations and performance evaluations. For more on this topic, please refer to my colleagues' research, or feel free to scan the QR code shown here, where you can access the web server that was developed. So I presented a description of the needs of different building professionals regarding interfaces for building documentations, and in fact they have unique needs for these types of interfaces. So I showed that real-time interactive building documentation is a feasible concept and can be implemented in a short amount of time. In fact, I did this in months. And we can create thereby an interactive geometry capturing and documentation approach. However, as this is a human-centered approach to this task, we need to study more about the HCAI aspects of the different user groups. And in the future, I'm planning to implement adaptation techniques for enabling human-centered and inclusive data collection between different ranges of professionals, but also different ranges of experience levels. So with this feasibility of this approach shown, in the future we are working towards direct building performance feedback, and this is possible by integrating AI and machine learning methods into this interactive data collection approach. This will also lead to more challenges that we will try to tackle. Thank you for your attention.